So we are still with working with right triangle trig. So that means sine, cosine, and tangent. That's what that means. Okay, but now we're going to be finding angles. So let me just show you what this is based on. The basic idea behind this is, let's say that I know how about I have a triangle and the side lengths are 5, 12, and 13. Remember that if we know the side lengths already, that we find the sine or we find the cosine or we find the tangent by just putting one over the other. It's a ratio. We just make a ratio. So let's say I wanted to find, I'm going to say QRS, the sine of angle Q. Then I would look at the opposite side. Okay, so here's Q. That means this is the hypotenuse. Remember that the angle itself is made up of the hypotenuse and the adjacent, so that makes this one here the adjacent. And 5 would be the opposite. So if I'm going to do opposite over hypotenuse, that's which number over which number?
Sine.
Okay, which number is opposite over hypotenuse? Which numbers?
5.
5 over 13. There you go. Okay, so 5 over 13. So if I was just being asked what is the sine, I'd basically be done. If you're given the side lengths and you're asked to find the sine, as long as you just want it in a fraction, you're done. If they said find it as a decimal, I would change 5/13 to a decimal. I would not push the sine button if they said change this to a decimal. Now what we're doing though is we're working a little bit backwards. Okay, we're saying, what is angle Q? It's like we're asking which angle would give me a sine of 5/13. Okay, so if we're working backwards, normally when you're working backwards and trying to find something that is missing, like for instance, let's say we have 5x equals 30. And I'm saying what number multiplies times 5 to give me 30, then I can do the opposite of multiplication. What's the opposite of multiplication? Division. I can divide both sides by 5. Okay? So normally when we are trying to find sort of the missing value or what would make this work, we use what we call an inverse. Division is the inverse of multiplication. So since x was being multiplied by 5, I do the opposite of that, the inverse of that, divide by 5, and I can figure it out. If I was doing a problem that was addition, what's the inverse of addition?
Subtraction.
Right, so I would subtract, and that would give me my answer. So basically, we need to do that here. The problem is this is not sine times Q. So if I want to get Q alone, I can't divide it by sine because that's not what this means. It does not mean sine times Q. Sine of Q is its own thing. It's different from multiplication. It's different from subtraction. It's its own type of thing that we do to an angle, is we find the sine ratio. So what we need is an inverse of sine. Just like multiplication has an inverse and it's division, or addition has an inverse and that's subtraction, sine has an inverse. Okay? And what it does is if I take the inverse of both sides, let me use a different color here, and it's indicated by this little -1 thing. Let me squeeze it in here. Then these cancel. And that leaves me with Q by itself equals the inverse sine of 5/13. Okay, so when you see these little sine, cosine, and tangent with a little -1, it does not mean to the -1 power. It's just a notation we use for the inverse. Okay, it looks like it's to the -1 power, but it just says basically inverse sine. So if you have this, this or this or this, these are the inverse functions, and it basically means we're working backwards and figuring out which angle would give us this answer. We already have the answer for the sine. We want to know which angle gave us this answer. Or we have the answer for the cosine. We need to know what angle would give us that answer. Another way of looking at it from this step right here, the easiest way in my mind, is if I want Q by itself, if I need to find the angle, that means I want Q by itself. I'm going to pick this up and move it to the other side. And just like things always change when you move them to the other side, when it goes to the other side, it now has the little -1 thing on it. Okay? If I want to figure out what Q is, I have to get sine away from it, and the only way to do that is to change it to inverse sine on the opposite side. This is, in my calculator, right above sine, right above cosine, right above tangent. That's where you see the inverses. Look on your calculator. And above sine, you'll see inverse sine. Above cosine, you'll see inverse cosine. And above tangent, you'll see inverse tan. So you have to use the second to get there. So I'm going to do it right now. I'm going to do inverse sine of 5/13, and that's 22.6.
Yep.
Inverse sine of 5/13 is 22.6. So what that tells me is that Q is about 22.6 degrees. A lot of times with degrees, a lot of times when we're doing angles, we go ahead and round it to the nearest whole number. So I would probably go ahead and take that up to 23 degrees. So in other words, if I take the sine of 23 in my calculator, sine of 22.6, really, sine of 22.6, this is, notice, just regular sine. Okay? I should get something that's pretty similar to 5/13, and it is. There's a little bit of rounding involved, so it's not going to necessarily be exactly the same, because I rounded to get to 22.6. Okay, so now if this is 23 degrees, how can I find this angle? Or how about subtract? Subtract 90 minus 23, and you get 67. Okay, so once you found one angle, the other one is just 90 minus that one. Now, you might wonder in this particular question or this particular problem, if you were asked for Q and you had all three sides, how would you know which two to use? You could use any two. You could use any two if you know all three sides. You just have to make sure you're using the correct ratio for the two you choose. If I choose to use opposite and hypotenuse, I'm going to go with sine and use the inverse sine. If I choose to use adjacent and opposite, I would use inverse tan. Okay, so let's look at this problem. Find the missing angles. Okay, now on this one, only two sides are given to me, so that makes it pretty easy to decide which sides I want to use. If we're asked to find both missing angles, I could start by either finding A or by finding B. It doesn't matter which one you start with. Okay, so I'm going to start with A. And I still start the same way as I always did. A lot of this stuff happens the same way as it always did. Like, you start by figuring out where the hypotenuse is. Which side here is the hypotenuse? That's the 23. Okay, that means that's hypotenuse. It meets adjacent at A, so this is adjacent. So 20 is opposite, yeah. Okay, so on this one, which sides am I working with? Opposite and hypotenuse, exactly. I don't need this one because it's not really involved with anything. So I'm going to use which function?
Sine.
Yep, sine. So sine of angle A equals opposite over hypotenuse. Please notice that I'm setting it up the same way I always do with that definition. I'm setting up an equation directly from the definition and filling in the things I know. Okay, I just don't happen to know the angle here, so I'm just calling it angle A. When you get to a point like this, and this is the only time you do this, is when you're trying to find the angle, and you realize you need A to be alone, but it has a sign next to it, that's when you have to say, oh, I guess I'm going to use that inverse thing to move it to the other side. Because this means A equals inverse sine of 20 over 23. Okay, so A equals inverse sine of 20 over 23. So I'm going to hit second sine to get inverse sine. Then 20 divided by 23. And I get 60.4. I'm going to go ahead and round that down to 60. The measure of angle A is about 60 degrees. Okay, if A is 60 degrees, then what's B?
30.
30, good. It's 30, 60, 90. Now let me point out something that's very important to realize here. A lot of times, once we learn how to do angles, students start using inverse sine, inverse cosine, inverse tangent all the time. Do not use the inverse all the time. Inverse is only for finding angles. Only for finding angles. I'm going to go ahead and start another one. We've got, and I want you to see how the angle is described on this one. Sometimes it'll just have a little symbol for the angle, like a variable. One of the most common symbols to use is actually a Greek letter, is the Greek letter theta. And it'll say find theta. Okay, and that just stands for the angle. So I'm going to say, what if I had this side is 7 and this side is 12.5? Okay, so you might have a situation like this. So theta, if you see the symbol theta, that always stands for an angle measure, so you're finding an angle. Finding an angle is the only time I use the inverses, so I know I'm going to use the inverses this time. Which side is 7? Opposite, hypotenuse, or adjacent? Okay, which side is 12.5? Adjacent. Guys, please sit down and be quiet. You're being rude. What do I use if I have opposite and adjacent?
And.
Yep. Still set up the equation. I should see this equation set up on your paper. Shh. Tan theta equals opposite over adjacent. So that's 7 over 12.5. Now if I need theta, I need to get the tan away from it, which means I'd move it where?
To tan -1.
Good. I move it to the other side as inverse tan, and this is what goes in my calculator. It's just like before that you don't, until the angle name is alone, you don't put anything in your calculator. And this is really not an angle name, it's the variable for the measure, but the same idea. So I'm going to do inverse tan of 7 divided by 12.5. And I get 29. Don't forget to do your homework.